this is Alma. Today we're going to be reviewing Unit 2, Mathematical Reasoning, Chapter 7, Geometry. Remember, as always, this video is intended to follow along with the GED Test Prep Plus 2020 Kaplan book. At any time during this video, you can pause and rewind. So why don't we go ahead and get started with our last chapter in Unit 2. Welcome back. As always, please remember that we are following along with the GED Test Prep Plus 2020 book. You can look down below for different places where you can go ahead and order it. During this video, we will be covering Unit 2, Mathematical Reasoning, Chapter 7, Geometry, Lessons 1 through 7. We will be starting on page 388. Lesson 1, Plane Figures. During the mathematical reasoning test, you will be asked to identify the characteristics of the different types of four-sided plane figures. Also, you will be asked to draw conclusions about their angles and sides. So you may be asking yourself, what are plane figures? Well, plane figures are simply sets of line segments. They are pretty much classified by the properties of their sides and angles. The sum of the interior angles of a four-sided plane figure will always be 360 degrees. Now remember this cute little fact because you're going to be using it when you are solving for a missing angle measurement, which you will be asked during the mathematical reasoning test. And another side note with plane figures is that sides with the same markings are equal, and you will see these markings on the following slides. Let's start by looking at some plane figures and its properties. You're very familiar with the first one, which is a rectangle. A rectangle is a four-sided figure with four right angles, meaning that if you were to add each angle of a rectangle, you will be getting 360 degrees, which is a property of a plane figure. Also with a rectangle, the opposite sides are the same length and they are parallel from each other. So if you look at the two horizontal lines on this rectangle, you will see that they have the same markings, meaning that they have the same length. On the other hand, the two vertical lines have the same markings as well. So that means that the two vertical lines have the same length too. Now let's look at another plane figure, a very familiar one, a square. So the square is also a four-sided figure with four right angles, and it also has opposite sides that are parallel from each other. However, the main difference between a rectangle and a square is that with a square, all four sides are the same length. Ergo, the same markings. So as you can see, all of the lines that form the square have the same markings, telling you that it is the same length and it's a square. Now let's look at a parallelogram. A parallelogram has opposite sides that are the same length and they are parallel from each other. Their opposite angles are equal in measure. And a special kind of parallelogram is called a rhombus because all four sides are of equal length. A trapezoid is a four-sided figure with one set of parallel sides. For this example, we are going to find the measurement of angle A. So this figure is A, B, C, and D, and it's telling us that the opposite sides are parallel. So AC is parallel to B and D, and then AB is parallel to C and D. We are also given a measurement of angle B, which is 110 degrees. So let's go ahead and first identify the figure. So we know that it's a parallelogram. Why do we know that? Because the opposite sides are the same. Remember that equal markings means that they are the same length. Also, opposite angles are equal in measurement. So now that we know that angle B is 100 degrees, let's find the measurement of angle C. So based on the parallelogram properties, opposite angles are equal in measurement, and angle C is opposite of angle B. Therefore, we know that the measurement of angle C is the same as the measurement of angle B. So they both measure 110 degrees. For the next step, now we're going to find the measurement of angle A. So we know that the measurement of angle A and the measurement of angle D are equal. And we also know that the sum of all the angles has to be 360 degrees, correct? So then how do we calculate that? Well, we're going to let x equal the measurement of angle A. But because we know that there's two angles that are going to have the same measurement, and that's angle A and angle D, we're going to have an equation of 2x. That means that we have two angles times whatever the measurement is of angle A. So in that case, we have 2x plus 110 degrees, which is the angle B, and then another 110 degrees, which is angle C, gives us a total of 360 degrees. Now, in order to solve this, you learned in the past lesson or the past chapter that what you do on one side, you have to do on the other. So let's go ahead and get started. So first off, let's combine like terms. So we have 110 plus 110 that are alike. They're like terms. So therefore, our equation becomes 2x plus 220 degrees, which gives us a total of 360 degrees. So now we want to cancel out the 220 degrees on one side because we eventually want to find out what x is. So what we do to one side, we do to the other. And in this case, because we have a positive sign on one side and we want to get rid of it, we are going to subtract 220 from both sides, leaving us with 2x on one side and 140 degrees on the other. Now the next step, in order to just isolate the x, we're going to have to divide by 2. So remember, what you do on one side, you have to do on the other. So when you divide 2x by 2, you get an x. And then when you divide 140 degrees by 2, you get 70 degrees. Therefore, the angle of the measurement of angle A is 70 degrees. Let's go ahead and put what we learned into practice. We're going to go now to practice 1, page 389. So for practice 1, we're going to complete questions 1 through 5 and 11 and 12. So for questions 1 through 5, you're going to list the names of the four-sided plane figures. And then for questions 11 and 12, you're going to choose the best answers. So go ahead and take a couple minutes, pause the video, complete the questions, and then come back when you're ready to review them together. All right, so let's get started. So here we have for question number 1, it's telling us that this shape or this figure has 4 right angles. And remember, we're only applying it to the shapes that we have already learned on page 388. So 4 right angles. I can think of 2. Can you think of 2? The rectangle and the square. For question 2, its opposite sides are equal in length. So let's think back to the rectangle, the square, the parallelogram, and the trapezoid. So, and we forgot one, the rhombus. So in this case, opposite sides are equal in length. It is all of them, parallelogram, rectangle, square, and the rhombus, with the exception of the trapezoid. Question number 3, exactly one pair of parallel sides. And that is a trapezoid. Remember that the trapezoid is a four-sided figure with only one pair of parallel sides. All angles are equal in measure. A rectangle and a square. And then question 5, only 3 right angles. Well, we know that plane figures is a set of line segments, and in this time we were only learning about four-sided plane figures. So our answer is none, because all the shapes that we have learned so far have all had 4 sides. For questions 11 and 12, we are going to be using figure E, F, G, H. Let's look at question 11. Angle F is 20 degrees more than 3 times the measurement of angle H. What is the measurement of angle F? Okay, it's a tricky one, but don't worry, we're going to solve it together. So let's start off by giving the angle H a variable. In this case, we're going to use H. Previous examples, we've used X and Y, but for this scenario, let's use H. So now it's telling us, let's go back to our question, and it's telling us that angle F is 20 degrees more than 3 times the measurement of angle H. So what does that look like in an expression? It looks like this. 3 times the measurement of angle H plus 20 degrees equals the measurement of angle F. Perfect. So now, because we know that all angles together for a plane figure, they have to equal 360 degrees. So now let's input that into our expression. So we have 3H plus 20 degrees plus H plus 90 degrees plus 90 degrees equals 360 degrees. Okay, so we're adding all angles together. Now, after this, we're going to solve it, or we're going to calculate it. Remember, we're going to start off by adding like terms. When we add like terms, we have 4H plus 200 degrees, which equals 360 degrees. And in this case, we want to isolate the H, right? Because that's going to be the measurement of angle H, and we need that in order to find out the measurement of angle F. So let's go ahead and take a look at this. So we have 4H plus 200 degrees equals 360. So in order to isolate the 4H, we're going to have to subtract 200 to cancel it from one side, but what we do on one side, we have to do on the other. So that leaves us with 4H divided by 160. Now, 4H equals 160 degrees. I'm getting ahead of myself. So now we are going to find the value of H, which is the measurement of angle H. So in order to do that, we're going to have to divide by 4 on one side and then divide by 4 on the other side. When we do that, we have H equals 40 degrees. So bam, the measurement for angle H is 40 degrees. So now we have to take those 40 degrees and plug it into our first equation that's going to give us the measurement for angle F. So let's go back to our first equation, which was 3H plus 20 degrees gives us the measurement of angle F. So when we replace 40 degrees instead of the H, we get 30 times 40 degrees plus 20 degrees, and that gives us 140 degrees. Therefore, the measurement of angle F is 140 degrees. Let's look at question 12. Remember, we are using the same figure, EFGH. Question 12 reads, in order for figure EFGH to be a trapezoid, which of the following must be a true statement? So let's look at our options. A, EF is the same length as FH. EF is parallel to GH. The measurement of angle F is the same as measurement of angle H. And the measurement of angle G is the same as the measurement for angle F. So let's look at the properties of a trapezoid. For a trapezoid, you need to have one pair of parallel lines. In this case, we have EF is parallel to GH. As far as our options go, that is the only correct statement that I see in order for the figure to be a trapezoid. EF is not the same length as FH, and the measurement of angle F is not the same as measurement in angle H as we saw in the previous problem. And then the measurement of angle G does not equal the measurement of angle F. So therefore, our answer is B. EF is parallel to GH. At this time, pause the video, complete practice questions 6 through 10 and 13 through 14, and click play when you are ready to continue. Let's move on to lesson 2, triangles. In the previous lessons, we learned about four-sided plane figures. During this lesson, we are going to learn about three-sided plane figures, or in other words, triangles. The properties of a triangle include three interior angles, three vertices. A vertex is a point where two or more curves, lines, or edges meet. A triangle is named by writing its vertices in any order. And one more important fact to remember about the three-sided plane figures or the triangles. The sum of all interior angles equals to 180 degrees. For example, if you look at this triangle here, this triangle can be named triangle DEF. Its sides are DE, EF, and DF. Let's look at different types of three-sided plane figures. These three-sided plane figures are classified by side lengths. So in the first one, we have an equilateral triangle. So just like its name says, equilateral means equal. So that means that all sides are equal in length and all angles are also equal in degrees. So for example, they all measure 60 degrees in this example, but they could all measure maybe 80 degrees or 30 degrees. As long as all angles are the same and all sides are equal, that is an equilateral triangle. The second three-sided plane figure is the isosceles triangle. So if you notice with the isosceles triangle, two sides are equal in length. Remember that we learned about those little markings back in lesson 1. So pretty much the same markings means that they are the same length. And then with an isosceles triangle, we have two angles opposite of these sides are equal. So as you can see with the isosceles triangle, we have two angles opposite of each other that equal 75 degrees each. Now for the last example of the three-sided plane figure, we have a scalene triangle. So with a scalene triangle, no sides are equal in length and no angles are equal. So what this means is that every side to this scalene triangle is different length. So one could be 1 centimeter, another one can be 3, and then another one can be 5 centimeters. And the angles are different as well. Now let's look at three-sided plane figures that are classified by angle measurement. So the first one, we have a right triangle, which means that this triangle has at least one right angle. And right angle measures 90 degrees. For the second triangle, we have an acute triangle. What this means, an acute, means that all angles measure less than 90 degrees. And then an obtuse triangle means that at least one angle is greater than 90 degrees. Remember that each triangle can be classified in two ways, angle and side length. So let's look at example 1 and determine what kind of triangle is triangle PQR. Just by looking at it, we see that it already has a 90-degree angle, and the side lengths, we have two side lengths that are the same and one that is different. So let's go ahead. Just keep that in mind when we are answering the question. So we're going to classify it first by its sides. Well, with its sides, we have two sides that are the same. So they are the same length. They both equal 10 centimeters each. So we can determine that triangle PQR is an isosceles triangle. Remember, an isosceles triangle has two sides that are equal in length. And next, we're going to classify it by its angles. So angle P, as we mentioned earlier, has a right angle. So triangle PQR is a right triangle. Remember that our right triangle has one angle that measures 90 degrees. So when we classify this triangle, this particular triangle with angle and side length, we can determine that triangle PQR is a right isosceles triangle. Okay, so we're going to calculate for a missing angle for this example. Remember that in the first slide, we talked about the sum of all interior angles equaling to 180 degrees. So for example, in triangle ABC, angle A measures 55 degrees and angle B measures 100 degrees. What is the measure of angle C? So let's go back to our algebraic expressions. So we're going to write an equation and we're going to solve it. Remember those variables x and y? Well, in this case, we're going to use the angle of C because that is what we're trying to find. So when we write an equation, we're going to add angle A plus angle B plus angle C. And we already know that the total of those three angles should give us 180 degrees. So now this is our expression. We have 55 degrees plus 100 degrees plus angle C, which gives us a total of 180 degrees. So next we're going to combine like terms. That means that we're going to add 55 degrees plus 100, which gives us 155 degrees plus the angle of C, which equals 180 degrees, 180 degrees. So in order to find the value or the measurement of angle C, we have to cancel out 155 degrees. So the way that we do that, it's inverse. So in this case, we're going to subtract 155 degrees from the left side. But whatever you do on the left side, you have to do it on the right side. So if you subtract minus 155 minus 155, that cancels it out. So you are left with just the angle C. And on the other side, on the right side, if you subtract 155 degrees minus 180, or 180 degrees subtracted by 155 degrees, you get 25 degrees. So therefore, you know that the measurement of angle C equals 25 degrees. Let's move on to our practice questions. So right now, go to practice 2, located on page 391. So for practice 2, we're going to complete questions 2, 5, and 7. For question 2, you're going to classify the triangle in 2 ways. For question 5, you're going to find the measurement of the unknown angle. And for question 7, you're going to choose the best answer. So take a few minutes right now to pause the video and complete questions 2, 5, and 7. When you're ready to continue, go ahead and press play. Great, you're back. So let's go ahead and get started. So with question 2, we're going to classify the triangle in 2 ways. Okay, so we have our triangle here. So first off, we can look at it and we can decide that all sides are different lengths. So we have one that's 4.5 centimeters. We have another side that's 9. And then the third side is 12 centimeters. So right off the bat, we know that these sides are not the same. And then we have an angle that is more than 90 degrees. Okay, so let's look at the way that we classify triangles. So an equilateral triangle has equal length. Well, that cannot be because our example here for question 2, they have different lengths. So let's move on to the next one. Isosceles triangle. An isosceles triangle has 2 sides that are equal in length. Well, once again, all sides are different, so it cannot be an isosceles. The third option is a scalene triangle, which means that no sides are equal in length. Well, that's the case. We have three sides that are different in length. Therefore, we can determine that this triangle is a scalene triangle. Now let's classify it by angle. So we have one angle that's more than 90 degrees. So both the right triangle and the acute triangle, you either have to have a right angle, which is 90 degrees, or an acute triangle, an angle that's less than 85 degrees. Well, with this triangle, we have one angle that's greater than 90. Therefore, it is an obtuse triangle. With an obtuse triangle, you have one angle that is greater than 90 degrees. And in this case, it's 115 degrees. So by looking at all the properties for the different triangles when we're classifying them by length and by angles, we can determine that this triangle here for question 2 is a scalene and obtuse triangle. So for question number 5, we're going to find the measurement of the unknown angle. So we have a triangle with a 90-degree angle, and then another angle 45 degree, and then we have the third one that's unknown. So let's go ahead and calculate it. So we know that the sum of all angles has to equal 180 degrees. Perfect. So let's go ahead and add all of the angles together to determine or to find the value of the unknown variable. So we have 45 degrees plus 90 degrees plus the unknown variable, which gives us a total of 180 degrees. So we're going to combine our like terms. In this case, it's 45 and 90. So it gives us a total of 135 degrees. So our new equation looks like this. 135 degrees plus the unknown variable equals 180 degrees. So then in order to find the unknown variable, we are going to do the inverse of the number that we have on the left and on the right side. So for example, on the left side we have 135. And in order to eliminate the 135 from the left side, we have to subtract it. So the inverse means the opposite. So we're going to subtract 135. But what we do on one side, we have to do on the other. So then we will subtract 135 from the left side and subtract 135 from the right side. That leaves us with 45 degrees. Therefore, our unknown angle is 45 degrees. Now let's look at question 7. We're going to choose the best answer. If angle DAB measures 115 degrees and angle DCB measures 95 degrees, what is the length of side AC in centimeters? Hint, use the facts in the problem to find the measurements of BAC and angle BCA. So let's go ahead and find the angle of BC, the measurement of angle BAC and the measurements of angle BCA, which is going to help us essentially find the length of side AC. So we know that the measurement of angle BAC plus the 55 degrees gives us a total of 115 degrees. So how do we know that? If you look back at our question, you can see that angle DAB is 115. So we have to combine 55 degrees plus whatever angle is BAC. So we're going to look at for the measurement of angle BAC first. So that leaves us with 60 degrees. Remember, we have to eliminate the 55 degrees from the left side in order to look for the variable. In this case, is the measurement of BAC. What we do on one side, we have to do it on the other. So therefore, we found the measurements of BAC, which is 60 degrees. Now let's find the measurement for BCA, which is the same thing. If you go back to the question, we know that angle DCB measures 95 degrees. So then when we write our equation, we're going to have angle BCA plus 35 degrees equals 95 degrees. So we're going to solve this equation. We're going to solve for the variable, in this case, the measurement of BCA, which gives us 60 degrees. So we already know, just based on the calculations, we know that angle BAC is 60 degrees and angle BCA also equals 60 degrees. We can determine that angle B also measures 60 degrees. So why? Because by looking at the two angles and with them measuring the same angle or measuring the same measurement, we know that an equilateral triangle has angles that are equal. In this case, 60 degrees. So two angles of triangle ABC equals 60, then the third one also measures 60. So the triangle, in fact, is an equilateral, which then states that if all sides are A, B, and C are equal to side A, therefore, side AB is 14 centimeters, and then side B and C is 14 centimeters, and side A and C is also 14 centimeters. Therefore, our answer is C, 14. At this time, pause the video, complete practice questions 1, 3, 4, 6, 8 through 9 and click play when you're ready to continue. Let's move on to Lesson 3, Pythagorean Relationship. During this lesson, we are going to learn about the Pythagorean relationship. The Pythagorean relationship focuses more on the right triangle. So let's review a little bit about the right triangle. Remember that with the right triangle, it has one right angle. A right angle measures 90 degrees. With the right triangle, the side that is across from the right angle is called the hypotenuse. The hypotenuse is the longest side of the right triangle. The remaining sides are the legs of the triangle. There is a special relationship among all three sides, the legs and the hypotenuse. This relationship is called the Pythagorean relationship. So with the Pythagorean relationship, you are able to solve the measurement of any side of a right angle or of a right triangle if the other sides are known. So the equation for the Pythagorean relationship is a squared plus b squared equals c squared. So a is the leg of the triangle, b is the other leg of the triangle, and c is the hypotenuse. Remember, c is the longest side of a right triangle. The square of the hypotenuse is equal to the sum of the squares of the two legs of the right triangle. Let's go ahead and practice. For example 1, what is the length of the hypotenuse of the right triangle shown in the diagram? So we have a right triangle with legs both different in size. One is 3 feet and the other one is 4 feet. Now the goal here is for us to find the hypotenuse. So let's assign a variable. For leg 1, it's going to be variable A. So that one's going to be 4 feet. Leg 2 is 3 feet, so we're going to assign variable B. And hypotenuse will be C. So now let's use the Pythagorean relationship in order to find the hypotenuse. Remember the equation? A squared plus B squared equals C squared. So let's replace all the variables with actual values. Remember that we gave the variable A, it was 4 feet, B was 3 feet, and C squared is the variable that we are trying to find. So here we have 4 squared plus 3 squared equals C squared. So 4 to the second power is 16. 3 to the second power is 9. So then we add common terms. We add 16 plus 9, which gives us a total of 25. But we still have C squared. And remember, the hypotenuse is only C. So therefore, in order to find the value of C, so this is the square root of C. Therefore, it's going to be the square root of 25. So the square root of 25 equals C. So what does that mean? It means that the hypotenuse is 5 feet because 5 to the second squared equals 25. Let's practice again. This time, let's use example 2. If John places a 13-foot ladder 3 feet from the base of the wall, how far up the wall will the ladder reach to the nearest tenth of a foot? So in this case, we are given the length or the measurement of the length of the hypotenuse and the measurement of one leg. So we are going to use our equation in order to find the size or the measurement of the other leg. And when we look at our example, we're going to find the measurement of how far up the wall will the ladder reach. So as we mentioned, the length of the triangles are 13 feet and 3 feet. Remember, 3 feet is a leg, and 13 feet is a hypotenuse because it's right across from the 90-degree angle. Let's assign the variables. Leg A is going to be 3 feet. The hypotenuse is going to be 13 feet, which we're going to assign variable C. And then leg 2, because it's an unknown variable, it's just going to be B. So let's use the Pythagorean relationship. Once again, a squared plus b squared equals c squared. So leg 1 plus leg 2 equals hypotenuse. But in this case, we have a value for leg A, which is 3 squared, but we don't have a value for b squared. So we're just going to write in b squared and leave it as a variable. But we do have the total of the hypotenuse, which is 13 squared. So our equation is going to look like this. 3 squared plus b squared equals 13 squared. So let's calculate it. So 3 squared is 9. Then we bring down the b squared, because remember, we're still trying to solve for b. Then 13 squared equals 169. So now, in order to find the variable of b squared, we have to subtract the 9. We have to do the opposite of what is there. So right here we have a positive 9. So we have to subtract by a negative 9 in order to remove it from the left side. But the same thing that we do on the left side, we have to do it on the right side. So therefore, when we subtract 9 from the left side, we are left with b squared. And when we subtract 9 from the right side, we are left with 160. So now we have b squared equals 160. That translates into b equals the square root of 160. Therefore, giving us the answer of 12.6 feet. So the ladder is going to reach a little bit more than 12.5 feet in distance. Let's move on to practice 3, found on page 393. For practice 3, we are going to answer questions 1, 2, 5, 11, and 12. So for questions 1, 2, and 5, you need to find the length of the remaining side to the nearest 10th unit. For question 11 and 12, choose the best answers. So take a couple minutes to complete these 5 questions, and when you are ready to review them together, just click play. So let's start with question 1. For question 1, we are given the measurements for leg A, B, and we have an unknown measurement of hypotenuse, which is C. So let's go ahead and use our Pythagorean relationship equation in order to solve for the hypotenuse. So we have here that leg A equals 8 inches, leg B equals 8 inches. So we are going to replace our variables with the numbers provided. In this case, we have 8 squared plus 8 squared equals c squared. When we simplify it, it's going to be 64 plus 64, giving us a total of 128. So then we have 128 equals c squared. So in other words, we need to find the square root of 128 in order to solve for the hypotenuse. We have an answer. So the square root of 128 is 11.3. Therefore, the hypotenuse is 11.3 inches. Let's move on to question 2. For question 2, we have leg A, 9 yards, leg B, 12 yards, and the hypotenuse is unknown. So here we go with our Pythagorean relationship equation. A squared plus B squared equals C squared. We are going to replace all the variables with the values that were given to us. So we have 9 squared plus 2 squared equals C squared. We're going to simplify it, which gives us a total of 81 plus 144. We're going to simplify it even more, and that's going to be 225 equals C squared. So when we simplify that, we are asked to calculate for the square root of 225, giving us an answer of 15. Therefore, the hypotenuse for this question is 15 yards. Remember to always put the measurement value that is given to you. For example, in question 1, it was inches, and in question 2, it is yards. Make sure that you add that. So now let's look at question 5. Question 5, we have leg A, 6 millimeters, leg B, it's unknown, and we have a hypotenuse, or C, of 10 millimeters. So here is our Pythagorean relationship equation. So we are going to replace all the variables with the numbers given. So in that case, we have 6 squared plus B squared equals 10 squared. So for this question, we are looking for the measurement of leg B. So let's go ahead and simplify our equation. So 6 squared gives us a total of 36. Then we bring down the B squared, which equals 10 squared equals 100. So remember that in order to isolate the variable B squared, we have to get rid of that 36. So in order to get rid of that 36, we have to inverse it, which means we have to do the opposite of what it is. So in this case, we have a positive 36. And if we subtract 36, they're going to cancel each other out and leaves us just with B squared. But what we do on one side, we have to do on the other. So 100 minus 36 gives us a total of 64. So we have B squared equals 64. And when we simplify it even more, we have the square root of 64. So B equals square root of 54, giving us an answer of 8. Therefore, the leg B equals 8 millimeters. Let's now look at question 11. The two shorter sides of a right triangle measure 18 feet and 24 feet. What is the measure in feet of the third side? Well, in this case, they are telling us that it is a right triangle. And in order to find the third side, which is the hypotenuse, we have to go back to our formula. Our previous formula was a squared plus b squared equals c squared. In this case, we are given the measurements of leg A and leg B, and leg C is what we have to find, which is the hypotenuse. So once we replace the variables with the values that we are given, we have 18 squared plus 24 squared equals c squared. When it gets simplified, we have 324 plus 576, which equals c squared. And then if we simplify it even more, we have 900 equaling c squared. But in order to find the measurement in feet of the hypotenuse, we have to take the square root of c, which in turn equals 30 squared feet. Or 30 feet. I'm sorry. It's 30 feet. So the answer is C. Now let's look at question 12. Jan has built a rectangular frame out of wood to use for the bottom of a platform. He wants to add a diagonal brace as shown in the drawing. So we have here a right triangle with measurements of leg A and leg B, and he wants us to find the diagonal measurement because they want to install a diagonal brace. So for this case, we're also going to use the Pythagorean relationship formula which is a squared, plus b squared equals c squared. And once again, we're looking for the hypotenuse. So let's go ahead and replace our values, our variables, with the values that are being given. So we have 5 squared plus 11 squared equals c squared. When we simplify it, we have 25 plus 121 equals c squared. Simplified even more, we have 146 equals c squared. But we need to find the square root of 146 in order to find the measurement in feet of the hypotenuse or the diagonal brace. In this case, the square root of 146 yields a result of D, 12.1 feet. At this time, pause the video, complete practice questions 3 to 4, 6 through 10, and 13. Click play when you are ready to continue. Before we begin lesson 4, I just wanted to check in and make sure that you're doing okay. We are coming up to the 1 hour mark, but I wanted to let you know that we still have a little bit ways to go. As you know, math is a little bit more complex unit, so therefore it is taking us a little bit longer, but don't worry, I am here and you can pause at any time to take a break. But let's go ahead and continue. Welcome. Let's move on to lesson 4, perimeter and area. In previous lessons, we have learned how to classify triangles, both by sides and by angles. We've also learned about 4-figure planes, which includes your rectangle and your rectangles and any quadrilateral. For lesson 4, we're going to learn how to find the distance around a figure. The distance around a figure is called the perimeter. So in order to find the perimeter, it's pretty much going to be the sum of the lengths of the sides. And here are the formulas for some simple common figures that we have: the square, the rectangle, and the triangle. So make sure that you remember or that you memorize these simple formulas because you're going to need them for the GED mathematical reasoning test. So to find a perimeter for a square, it's 4 times a side. Rectangle, the perimeter is 2 times the length plus 2 times its width. In a triangle, you're going to find the perimeter by adding side 1, side 2, and side 3. So let's go ahead and take a look at example 1. A rectangle is 16 inches long and 9 inches wide. What is the perimeter of the rectangle? So we're going to use the formula to find the perimeter of a rectangle. And the formula is 2 times its length plus 2 times its width. So when we replace the length, in this instance it's 16, we're going to multiply that by 2, and then we're going to add it to 2 times 9 because that is the width. When we do that, we get 32 plus 18, yielding a result of 15 inches. So therefore, the perimeter of the rectangle is 50 inches. See? It's not that bad. You just need a little practice. So now let's find the area of a figure. So the area is the measurement of space inside the figure. So we talked about the outside, which was the perimeter, but now inside is the area. The area is measured in squared units. So for example, if you're measuring in inches, then the area will be measured in square inches. If they were feet, then it would be squared feet. So here are the formulas to finding the areas. So in order to find the area of a square, it's s to the power of 2. The rectangle is length times its width. A parallelogram is base times its height. A triangle, it's 1/2 times the base times the height. A trapezoid is 1/2 times the height times the base 1 plus base 2. Don't worry, we will apply these formulas to the following examples. If you can see here the formulas, we have 2 new measurements that we haven't talked about before. One of them is the base, and then the other one is the height. So if you look at the diagrams, you can see that the base is one side of the figure. For the trapezoid, you can see that there are 2 bases. You have base 1 and then base 2. But for a triangle, you only have the bottom base. The height is the length from the vertex to the base, forming a right angle to the base. So let's go ahead and practice. Example 2 states, to find the area of figure A, B, C, and D. So just looking at the diagram, we see that we have a height of 7 centimeters and we have a base of 12 centimeters. Okay, so let's go ahead, because this is a parallelogram, which is going to be the first step eventually, is to identify the figure. So right away we can see that it's a parallelogram. So we go back to our formulas in order to find the area of a parallelogram, and it is base times its height. So we're given a base, so find the facts that you need on your diagram. So we have a height of 7 centimeters. Remember, the height is a line from the vertex to the base. And then we have a base of 12 centimeters. So now let's calculate. Remember, the area is base times its height. So we're going to replace the values with the variables, which gives us 12 times 7. And in total, the area of the parallelogram is 84 square centimeters, or 84 centimeters squared. Either way is correct. Let's move on to practice 4, located on page 395. For practice 4, we are going to be answering questions 1, 6, 9, and 10. For questions 1 and 6, you're going to find the area and perimeter. And then for questions 9 and 10, you're going to choose the best answer. So go ahead and take a few minutes to complete this by yourselves. And then once you're ready to review them together, just go ahead and click play. Let's start with question 1 and 6. So for questions 1 and 6, we're going to find the area and perimeter for each. So question 1 is a triangle. In order to find the perimeter of a triangle, you have to add all sides. So here we have 7.8 plus 10 plus 13, which are our sides. Disregard the 6 at this time because that is the height which we will be using for the area. So when you calculate these numbers, when you add all the sides together, you get a perimeter of 30.8 units. So now let's calculate the area. When you calculate the area for a triangle, it's 1/2 times its base times its height. So now at this time, we are going to use the 6, which is the height. Remember, the height goes from one vertex to the base. It's a straight line. And so it's going to be base times height. So we have 13 times 6, which gives us a total of 78. And then we're going to multiply that times 1/2, which yields a result of 39 square units. Now let's look at question 6. So question 6, we have a rectangle. In order to find the perimeter of a rectangle, it's 2 times its length plus 2 times its width. We're going to replace the variables with the given values. So the length in this case is 12 units and the width is 4 units. So when we calculate, we have 2 times 12 equals 24 plus 2 times 4, which gives us 8. When we calculate 24 plus 8, we get a perimeter of 32 units. In order to find the area for this figure, it's going to be a little tricky because the area is going to be, we're using the formula of a trapezoid. The reason being is because we have a height that takes us from one vertex to the base in order to make a 90-degree angle. So as you can see right here, if you disregard that middle line, you can see a trapezoid. Therefore, we're going to use the formula of a trapezoid. The formula of a trapezoid is 1/2 times its height times the base 1 plus base 2. So we know all those numbers. So let's go ahead and replace the variables with the values given. So we have a height of 9.5, base 1 is 4, and base 2 is 4. So when we calculate that, we have 9 times 5, 9.5 times 4 plus 4, all of it multiplied by 1.5, which gives us 38 square units. Let's move on to questions 9 and 10. For questions 9 and 10, we are going to choose the best answer. So let's read number 9. Martin is building a rectangular patio centered on one side of his yard. The rest of his yard is planted in grass. If the measurements in the diagram are in feet, what is the square footage of the grass portion of Martin's yard? Okay, so they are looking for the square footage of the grass area only. But in this case, we have the patio and the grassy area. So let's go ahead and calculate this. So first off, we're going to find the area of the patio. And I will tell you why in a minute. So the area of the patio, we were told that it was a rectangle. And in order to find the area of a rectangle, it's its length times its width. So we're going to replace those variables with the values. In this case, it's 9 and 12. So that yields a result of 108. That is the square footage or the area square footage for the patio itself. Now, let's find the square footage for the yard. Once again, we were told it's a rectangle, so we're going to multiply the length times its width in order to get the area of the yard. We're going to replace those values with 18 and 24, yielding a result of 432. Now, what we're going to do is we're going to subtract the yard or the patio from the yard because we only want the area of the grass. So in order to do this, we already have our area. So it's going to be 432 minus the square footage of the patio, which is 108, yielding a result of 324 square feet. Now let's look at question 10. A square measures 6 centimeters on one side. What is the perimeter of the square in centimeters? The formula to find the perimeter of a square is 4 times its side. In this case, the side is 6 centimeters. So when we calculate it, we find that the perimeter is 24 centimeters. So your answer is B. At this time, pause the video, complete practice questions 2 through 5 and 7 through 8. Click play when you are ready to continue. We are now moving on to Lesson 5, Circles. We have been learning about triangles, rectangles, squares, trapezoids, so pretty much any plane figure that has a side to it. Well, circles don't have any sides. They are a closed set of points that are all the same distance from a single point or the center distance. In order to find the perimeter of a circle, you need special formulas and other measurements within the circle. But the perimeter in a circle, in this case, it's called circumference, and that is the distance around the circle. The area of a circle is the space inside the circle. So finding the perimeter and the area, as I mentioned before, you need other measurements than just the height or the base, because in this case, we do not have any bases. So let's look at the different measurements that we need to find the perimeter and an area. So first of all, we need a diameter. As you can see in the diagram, the diameter is a line segment with endpoints on the circle that passes through the center of the circle. So it's pretty much a line that goes from one end to the other. That is your diameter. Your radius is a line segment that connects the center of the circle to any point on the circle. So you could say that the radius is 1/2 the diameter. So keep that in mind for our future examples and practices. In order to find the perimeter and the area of a circle, we use a special formula, which includes pi. No, not the pie that you eat, but pi in mathematical reasoning or mathematical equations. So pi is a special quantity used to solve for the circumference and the area. And the pi is it's equal to approximately 3.14 because it is an infinite number. So pi is the ratio of the circumference to the diameter. So let's look at some of the formulas that we will be using in order to find perimeter and area. So we have a circumference formula is pi times the diameter. In order to find the area of a circle, it is pi times the radius to the second power. There will be instances when you will be asked to find the diameter of a circle in order to solve for the circumference, and also for the radius of a circle in order to solve for the diameter. So they kind of all intertwine together. The diameter formula is d, which is equals diameter, equals 2 times the radius. Remember that we said the radius was 1/2 the diameter? So this is where our formula comes in. And then we have a radius formula as well, which is 1/2 times the diameter. So let's look at example 1. A china plate has a gold rim. If the plate's diameter is 10.5 inches, what is the distance around the rim to the nearest tenth of an inch? So in this example, they are asking us to find the circumference. Remember, the circumference is the distance around the circle. In this example, it will be around the gold rim. So then we're going to use the formula circumference equals pi times diameter. So we already know pi equals 3.14 because that's an infinite number. And the diameter was given to us in the example, which is 10.5 inches. When we multiply the pi and diameter, we have an answer of 32.97, but when we round it out to the nearest tenth of an inch, it gives us 33 inches. Let's move on to example 2. The circular surface of a satellite component must be covered with heat-resistant tiles. If the radius of the component is 4 meters, what is the area in square meters? So in this example, it's asking us to find the area. So the formula to finding the area is pi times radius squared. So we were given the radius in this example, which is 4 meters. So now we're going to replace our variables with the values given. So pi, we know that it's 3.14. In radius, on the example, it's telling us that it's 4 meters. So then our equation is 3.14 times 4 to the second power. So we are going to first remember the order of operations. Before we multiply, we have to complete the exponents. So let's go ahead and have 4 to the second power, which will be 16. So therefore, our new equation is 3.14 times 16. When we multiply that, we have an area of 50.24 square meters. See, not bad. Let's look at example 3. What is the circumference of circle B to the nearest tenth of a centimeter? So circumference is pi times diameter. Well, in this example, we are not given the value of the diameter, so we have to find it. In order to find the diameter, the formula is 2 times the radius. So we were given a value for the radius. So let's go ahead and substitute or replace our variables with the values given. So in this instance, we're looking for the diameter, which is 2 times radius. We're going to replace the variable r with 5, and that gives us a diameter of 10. So now that we have our diameter, now we can go ahead and solve for the circumference. Remember, circumference is pi times d. So we're going to replace the variables with the values. So in this instance, we have 3.14 times 10, which gives us an answer of 31.4 centimeters. At this time, let's move on to practice 5, found on page 397. For practice 5, we are going to answer questions 1, 3, 6, and 7. So for questions 1 and 3, you're going to find the circumference and the area. And for questions 6 and 7, you're going to choose the best answer. So take a few minutes to complete these 4 questions. Once you're ready to review them together, just click play. Let's start with question 1. For question 1, we are going to find the circumference and the area, which will be the same for question 3. So let's go ahead and get started. So for question 1, we have a circle with a radius of 10 inches. So we know that the circumference formula is pi times the diameter, and the area is pi times radius squared. So let's start with the circumference. So for the circumference, we don't have a diameter, but we do have a radius, and we do have a formula to find the diameter. So the formula to find the diameter is 2 times the radius. So in this case, it's going to be 2 times 10. 2 times 10 gives us a diameter of 20. Now we can solve for our circumference, which is 3.1 times 20 gives us a circumference of 62.8 inches. Pretty easy, right? So now let's find the area. So the area is pi times radius squared. So let's substitute or replace the variables with our actual values. So we have for area 3.14 times 10 to the second power, which gives a total of 314 square inches or 314 inches squared, whatever is your preference. Let's now move on to question 3. So for question 3, same thing. We're going to find the circumference, which is pi times d, and the area, which is pi times r squared. So once again, it looks like we were not given a diameter, but we were given a radius. So in order to find the diameter of this circle, we're going to have to use our formula for the diameter. So diameter equals 2 times the radius. In this instance, our radius is 4 meters. So the diameter will be 2 times 4, giving us a total of 8 meters. So we found our diameter. Now we can move on and solve for the circumference. So let's replace all the values with the variables, or vice versa, sorry. So the circumference is 3.14, remember that's pi, times 8, which gives us a circumference total of 25.1 meters. Now let's do the same thing for the area. The area is pi times radius squared. So that will be 3.14 times 4 to the second power. When we solve that equation, we get an answer of 50.2 square meters or 50.2 meters squared. Either one is correct. So for question 6, we are going to choose the best answer. Let's read it together. The radius of a circle is 6.5 centimeters. What is the diameter of the circle in centimeters? Okay, so this one does not have a figure or a diagram. So you can definitely do one on a paper if you're a visual learner. If not, you can do it in your head. So let's start with the diameter formula because that's what they want us to find. So the diameter equals 2 times the radius. And we were given the radius, which is 6.5. So right now, we're just going to replace our variable with the value, which is 2 times 6.5, which gives us an answer of 13. So if you chose B, you are correct. Let's move on to question 7. So for question 7, we're also going to choose the best answer. Question 7 reads, on the target below, or to the side, the 5 and 10-point bands are each 2 inches wide, and the 25-point inner circle has a diameter of 2 inches. To the nearest inch, what is the outer circumference of the 10-point band? So we're trying to find the distance around the second circle, the 10-point band. So if you look at the diagram, we already have the diameter of the 25-point circle, which is 2 inches, and then we have the length or how much, or the inches, the width of the 10-point circle. So let's go ahead and solve. So first, we have to find the diameter of the 10-point band in order to solve for the circumference, because circumference is pi times diameter. So the diameter for the 10-point circle passes, it's that orange line, it passes through the 10-point circle once, and then 10-point circle twice, and the 25-point band. So essentially what this is telling us is that the diameter is going to be the inner circle the measurement of the inner circle plus the 10-point band where it starts, and then the 10-point band where it ends. So that's how we're going to get our diameter. So we pretty much already have those numbers. So we know that the diameter of the inner circle, which is the 25-point inner circle, the diameter is 2. Remember, the diameter goes from one end to the other. So that's a total of 2. Now the 10-point band from one side equals 2 inches, which was already given to us on the question. But because the diameter passes through it twice on the other side as well, we're also going to add those additional 2 inches. Therefore, the diameter of the circle here, or the 10-point circle only, is 10 inches. So now that we have the diameter, now we can measure for the circumference. So the circumference is pi times diameter. So we're going to replace the variables with their values, 3.14 times 6, which gives us a total of 18.84. But in this instance, they want us to find the circumference to the nearest inch. So in this case, when we round it off, it's 19. Therefore, our answer is C. At this time, pause the video, complete practice questions 2, 4, and 5, and click play when you are ready to continue. We are now moving on to lesson 6, volume. In previous lessons, we talked about the area and we talked about diameter, circumference, radius, along with other formulas. Well, in this instance, or in this lesson, we are going to focus on volume. So what is volume? The volume is the capacity, or pretty much it's the measurement of space inside a three-dimensional object. So how much of it fits inside an object? So the volume is measured in cubic units. So ultimately, the number is how many cubes would you need to fill an object? So let's think of some three-dimensional objects that have at least 2 identical and parallel faces. For example, that could be a cereal box. As you can see, the top and the bottom of the box are identical. So those can be called faces, or in this case, a base. So either face can be the base of the object. And that is more for a rectangular prism. Volume can be found multiplying the area of one base by the height of the object. So volume equals area of base times height. But what if you don't have a rectangular prism? What if you have another three-dimensional object, such as a cube, a cylinder, or a sphere? Well, don't worry. Here on the slide, you can see that I've listed down the formulas to find the volume of each of those three-dimensional objects. In the previous slides, we looked at some formulas in order to find the value of some three-dimensional objects. Well, let's go ahead and do some examples in order to get better at it. Remember, practice makes perfect. So for example 1, a cardboard box has the dimensions shown in the diagram. What is the volume of the box in cubic feet? So first off, we have to determine what kind of three-dimensional object this is. So we know that it's not a cube. We also know that it's not a cylinder. And definitely it's not a sphere. So we can determine that this object is a rectangular prism. So with a rectangular prism, it has 2 identical bases. So for example, on the box where it says 4 feet, the opposite base is also going to be 4 feet. While where it says 5 feet, the opposite base is going to also be 5 feet. Therefore, they're identical bases. So let's look at the formula. The formula for a rectangular prism is volume equals base times height. So let's go ahead and replace the variables with the values that are being given. So we have 4 times 5. Remember, we have to use the measurements for both bases in order to find the volume. So it's 4 times 5 times 3. So therefore, it equals 60 cubic feet or 60 feet cubed. So let's look at another example. A wood block measures 2 inches per edge. What is the volume of the block? So for this instance, this is not a rectangular prism. So let's identify what kind of three-dimensional object this one is. So it talks about edges. So I remember looking at the formulas that in one of the formulas we used the edge in order to find the volume. Do you recall what that was? And it's okay if you want to go back to the previous slide and take a look at it. Don't worry. So it was a cube. So the cube is a rectangular prism with 6 identical faces. So in a cube, each edge is the same length. So all of it is going to be pretty much the same, which is 2 inches per edge. In order to find the volume of a cube, it is equal the edge to the 3rd power. So we're going to replace the variable with the value given, which in this case, the measurement was 2 inches. So the volume of the cube, when you take 2 to the 3rd power, is going to be 8 cubic inches. You can write it in either format. Let's look at example 3. A storage tank has a radius of 1.5 meters and a height of 3 meters. What is the volume of the tank to the nearest cubic meter? Okay, so here we have the cylinder, and the cylinder gives us a radius. Remember, the radius is half the diameter. The diameter is a straight line going from one end to another in the circle. Okay, so here we're given half the diameter, which in other words is the radius, and we're given the height of the cylinder. So the cylinder has 2 circular bases, and the bases are connected by a curved surface. So the formula to find the volume of a cylinder is pi times radius squared times the height. So let's go ahead and replace our values. Let's replace the variables with the values that are being given. So remember, with the previous lessons, we learned that pi equals 3.14. So it's going to be 3.14 times the radius squared. In this case, it's 1.5 squared times the height, which is 3. When we calculate that, so we're going to simplify it even more. So the 1.5 squared is 2.25, and when you simplify it, you get 21 cubic meters. So therefore, the volume for the tank is 21 cubic meters. At this point, let's move on to practice 6.1, located on page 399. So for practice 6.1, we're going to answer questions 1 and 8. For question 1, you're going to find the volume. For question 2, you're going to choose the best answer. So take a couple minutes to complete both questions 1 and 8, and then when you're ready to review them together, just go ahead and click play. Perfect, welcome back. So let's go ahead and start with question 1. So question 1 is asking us to find the volume. So in this case, we have a shape. What kind of shape is it? Well, it looks like it could be a rectangular prism because it doesn't look like a cube, a cylinder, or a sphere. Therefore, the formula for a rectangular prism is volume equals base times height. So remember, we have 2 bases and we have 1 height. So let's replace the variables with the values given. So in this instance, it's going to be the base, which is 5 times 8, because remember we have 2 bases here, times 4, which is the height. That gives us an answer of 160 cubic units. So now let's look at number 8. A wooden crate measures 5 feet along each edge. What is the crate's volume in cubic feet? So think about what a crate looks like. So now, a crate, and the other thing that we have to infer for this question is that they are talking about an edge. So anytime you hear a question mentioning an edge, automatically you should go to cube. Because remember, the volume for a cube equals edge to the 3rd power. So in this case, we can infer that the wooden crate is a cube and each edge is 5 feet. So therefore, the formula for volume of a cube is the edge to the 3rd power. So let's replace the variables with the value that's being given. So in this case, it's telling us that each edge is 5 feet. So let's replace it with 5 feet. And when we take 5 to the 3rd power, we get 125 cubic feet. At this time, pause the video, complete practice questions 2 through 7 and 9, and click play when you are ready to continue. Now let's learn about finding volumes for a 3-dimensional object with 4 triangle faces that connect to the same vertex, or in other words, the pyramid. So the basis of a pyramid can be any closed figure. For the GED mathematical reasoning test, you will only have square bases. So as you can see in the following diagrams, we have a rectangular prism and we have a pyramid. They both have identical square bases and the same height. Let's compare the 2 figures. So as you can see, the pyramid holds much less than the rectangular prism. In fact, it only holds 1/3 of the rectangular prism's volume. The formula for finding the volume of a pyramid is volume equals 1/3 times the base times the height. Notice that the base in the volume of a pyramid is the same equation to find the area of a square. Do you remember that back in lesson, I want to say 4, maybe? But it was one of the previous lessons. Okay, so just remember that. So now let's talk about the volume of cones. So the cones they have a circular base and a curved side that resembles a cylinder. So the curved side is slanted inward, So then it has a vertex, so it has a point. So think about a cone, think about a party hat. You know, when you go to birthday parties, they give you a little party hat. So that's a cone. Okay, so in order to find the cone, it is the volume of a cone, it's 1/3 of the volume of a cylinder with the same size, base, and height. So what that translates is 1/3 times pi, because remember, a cylinder, the base of the cylinder is a circle. So we are going back to pi from the previous lesson, times the radius squared, which is half of the diameter, times its height. So let's practice a little bit. So I gave you the formulas to find the volumes for pyramids and cones. So for example 1, let's find the volume of the pyramid. So we're going to apply the formula, which is 1/3 base times height. So we're going to replace the variables with the values that were given to us. So it's going to be 1/3 times 5 squared. Remember, we're looking for the base, and the base of a square, it's side squared. Okay, so pretty much it's the measurement of the side to the second power. Think back to the area of a square in previous lessons. Times 6. So when we calculate this, so you're going to first do the exponents, which is 5 to the second power is 25. Then you're going to calculate the equation, and you will get 50 cubic centimeters. Now let's look at example 2. For example 2, they want us to find the volume of the cone. Okay, so we have a cone. Remember, think party hat. So let's apply the formula. So the formula is 1/3 times pi times radius squared times height. So let's replace the variables with the values that are being given. So we have 1/3 times pi, which is 3.14, times 2 squared, because radius is 2, times the height, which is 9. So we're going to take 2 to the 4th power. We have to do that before we do anything else. Always go back to your order of operations. And that will give us an answer of 37.68 cubic inches. Let's move on to practice 6.2, found on page 401. So for practice 6.2, we are going to complete questions 5 and 8. So for question 5, I need you to find the volume. And for question 8, you're going to choose the best answer. So take a few minutes to complete these questions, and when you're ready to come back, then you push play. So let's start with question 5. So for question 5, we're going to find the volume. So this looks like a pyramid. It does not look like a cone because it has a squared base. Remember? Square area equals side squared. So let's look at the formula. The formula is volume equals 1/3 times the base times the height. So we're going to replace the variables with our values. Once again, the base is 2 squared. Always remember that. And when we calculate it, we get 10.66, but when we round it off, it's going to be 11 cubic inches. So let's look at question 8. The height of a cone is half the diameter of the base. If the cone's height is 4 inches, what is the cone's volume to the nearest cubic inch? So for the volume, to find the volume of the cone, it is 1/3 times pi times radius squared times the height. However, as you can see, they did not give us the radius here, but they did give us a clue. So it says that the height of a cone is half the diameter of its base. If the cone's height is 4 inches, so right away, they are telling you that the cone's height is half the diameter. So by the cone being 4 inches, it's telling us that the entire diameter is 4 inches. But when you cut that in half, the radius is cut in half, that's 4 inches. So we have 1/3 times pi, which is 3.14, times 4 squared times 4, which is the height. When we calculate that, we get 66.9, but we're going to round it, which gives us 71 cubic inches. At this time, pause the video, complete practice questions 1 through 4, 6 through 7, and 9 through 10. When you're ready to continue, click play. Let's move on to lesson 7, surface area. The surface area is the total area of the outside faces of three-dimensional figures. This is different from volume because the volume is what a figure can hold. The surface area of a square prism or a cube equals the sum of the areas of the 6 squares that form the prism. So all 6 faces. So the area of one square is side squared. So when the sides of a square is the same, you find the area of one side and multiply it by 6 because essentially it's all of them together being added. So let's go ahead and look at example 1. Find the surface area of a cube with sides of 3 inches each. So we already know that our formula to find the surface area of a cube is 6 times the side square. That's because we know that all the sides of the cube or all the faces are the same measurement. So in this instance, it's 3 inches. So when we replace the value of the face with the variable, we are going to get 6 times 3 inches squared equals, remember we are going to first do the exponent. So we're going to take 3 to the second power, which is 9, and we're going to take the inches to the second power as well, which is squared, inches squared. So that was give us a total of 54 inches squared, or squared inches. Let's now learn how to find the surface area of a rectangular prism. So the sum of the areas of the 6 squares that form the prism, kind of like the cube. But with the difference of a rectangular prism, that you're going to use several formulas in order to calculate the surface area of a rectangular prism. Because the surface area is the perimeter times the height plus 2 times the area of base. So let's look at our example 2. We need to find the surface area of the box or the rectangular prism. So here is our formula in order to calculate the surface area. So why do we have 5 plus 6 plus 5 plus 6? So remember that the perimeter of a rectangle, it's 2 times the length plus 2 times the width. But in this case, we are just going to write out all the sides added together. So in this instance, we have the sides equaling 5 meters, 6 meters. So we know that the opposite sides are going to be the same measurements. So therefore, we're also going to add another 5 and another 6 because the perimeter is going to be the entire base area. So then that we're going to multiply times the height, which is 7 meters, plus 2 times the area of the base. The area of the base is the length times the width, which is 5 times 6. So do you remember that we were using multiple formulas in order to find the answer for this question? So this is what I mean. So make sure that you remember or that you at least write down the different formulas that you need in order to find the volume, perimeter, radius, surface area, as we are going to continue to need them for the remainder of this chapter. So when we simplify our equation, we get 22 times 7 plus 2 times 30. We simplify it even more, so we have 154 plus 60, which yields a result of 214 square meters. Since we learned the surface of a square prism or a cube, and how to find the surface area of a rectangular prism, it is only fair to also learn how to find the surface area of a pyramid. In order to find the surface area of a pyramid, it's half the perimeter of the base, which is represented by P, times the slant height, which is represented by the variable S, plus the area of the base, which is capital B. The slant height is the length of the line segment from the apex or from the top of a period to the base or to the bottom. So let's look at example 3. What is the surface area of a pyramid with a slant height of 5 feet, a base with a perimeter of 14 feet, and a base with an area of 12 feet? So here is our formula. The surface area equals half the perimeter of the base times the slant height plus B. So let's go ahead and replace these variables with the values that are given to us. In this case, we have the perimeter of the base, which is 14, as you read in the example. It tells us that the base has a perimeter of 14. And then the slant height, it's 5, so we add the 5 for the slant height, plus the area of a base, which is 12 feet. So once we have replaced all of the values in there, or all the variables with our values, then we're going to go ahead and calculate it. So remember the order of operations. You cannot do one thing before the other, otherwise you're going to get the wrong answer. So in this case, we're going to start with multiplication. So you're going to multiply 14 times 5, which gives us 70. So our new answer or our new equation is 1/2 times 70 plus 12. Once we simplify it, we get 35 plus 12. And ultimately, when we simplify it even more, we get our answer, which is 47 feet squared. Since we have finished lesson 7.1, now let's focus on its practice. So go to page 335 to complete practice 7.1. For practice 7.1, complete questions 2 and 9. For question 2, you are being asked to find the surface area. And for question 9, you are being asked to choose the best answer. So go ahead and click pause at this time and complete both questions and come back so we can review them together. Let's start with question 2. Find the surface area. So here we have a pyramid, which is the first step. We need to identify the figure. It is a pyramid with a point at the top or an apex. And we're also given a slant height of 5 inches. In order to calculate the surface area, it is 1/2 times its perimeter times its slant height plus the area of the base. So unlike the previous example that we were given, we got the perimeter base. In this case, we didn't. So we have to calculate. But in order to calculate it, we have to determine what shape the base is. So based on the figure, it's telling us that all sides at the bottom are the same, leading us to believe that the base is a square. In order to find the perimeter of a square, it's 4 times its sides because the sides are all the same. So when we replace the variable s with the value of 3, we get 12. So in that case, it's 4 times 3 equals 12. So our perimeter for the pyramid is 12. Now we're going to calculate the area of the base. Once again, we're going to use the formula that is used at a square because our base is a square. In order to find the area of the base, it's s to the second power. So in this case, s, or side, is 3 inches. So the area of the base is 3 to the second power. Now, we can go ahead and replace our variables with values or with numbers. So it's 1/2 times perimeter of the base, which is 12, times the slant, the slant or the height slant of the pyramid, which is 5, plus the area of the base, which is 3 squared. When we calculate it all together, we have an answer of 39 square inches. Oops, sorry, ignore that. So now for question 9, let's read it together. If the dimensions of the box are doubled, by how many square centimeters does the surface area increase? So here we have a box, a cube, a prism cube, right? A square prism or a cube. So in order to find the surface area of a cube, remember, so this goes back to what I had told you earlier in the beginning, that when all the sides are the same, so you just have to multiply one side or multiply 6 times the side square because all the sides are the same. So in that case, our formula is 6 side squared. So when we replace it with the value, we have 6 times 3 to the second power, which is 54. Okay, so that is the surface area when we have sides of 3. So now the question is asking, what if the measurements were doubled? So what double means is that they're, instead of 3 centimeters, they are now 6 centimeters. So let's go ahead and replace the 3 with 6 now. So we have 6 times 6 to the second power, which gives us a total of 216. Well, they want to know the difference. So by how many square centimeters does the surface area increase? So in order to find that number, we're going to subtract 26 minus 54, and that gives us an answer of 162. So if you chose C, you are correct. At this time, pause the video, complete practice questions 1 and 3 through 8, and click play when you are ready to continue. As it is customary in the previous lessons, when we found the volume, the perimeter for one shape, we found it for all shapes out there. So now we're going to find the surface area of a cylinder, a cone, and a sphere. In order to find the surface area of a cylinder, you're going to multiply the circumference. So the circumference is around the object. So that's a measurement around the object, which is 2 pi r. So you may be wondering, where do we get that formula from? Well, this formula goes back to the lesson where we learned about circles. Because remember, a cylinder is a circular figure. Then you're going to multiply the circumference by the height, which is h, and then you're going to add that product to the area of the two ends of the cylinder, so the top and the bottom. And the area of a circle is pi r squared. So that's where we get the 2 in our formula, which is 2 times pi r squared, because we have a top and a bottom side. Now the surface area of a cone, you're going to combine the lateral side surface with the area of its base. So that means the lateral side surface is pi r times the slant height. And the area of the base is pi r squared. So this is the same formula that we find the area of a circle. Remember, because the base of the cone is a circle. Therefore, we're using that formula. So then you have surface area of a cone equals pi times radius times slant height plus pi times its radius squared. Now let's find the area, the surface area of a sphere. So it's just 4 times the area of a circle. So we have 4 times the area of a circle, which is pi r squared. So just a little hint, when you're looking to find the surface area of any cylindrical shape, such as a cylinder, a cone, or a sphere, you're using the surface, in order to find the surface area, you're using the formulas from the circles, from dimensions of a circle. Just keep that in mind whenever you come across any objects like these. Let us practice finding the surface area of a cylinder, a cone, and a sphere. For example 1, we have find the surface area of a cylinder with a radius of 4 inches and a height of 3 inches. So we're going to start off by writing out our formula. Remember the formula to find the surface area of a cylinder? It's 2 times pi times radius times height plus 2 times pi times radius to the second power. So we're going to substitute all of our values for the variables. So here you go. So you have 2 times 3.14 times 4 times 3 plus 2 times 3.14 times 4 squared. So when we simplify that, we have 75.36 plus 100.48, giving us a surface area of a cylinder of 175.884 inches squared. Pretty easy, right? So now let's focus on finding the surface area of a cone. So example 2 is asking us to find the surface area of a cone with a radius of 2 feet and a slant height of 5 feet. So first off, let's start with our formula. So the formula for the surface area is pi times radius times the slant height plus pi times radius squared. So now let's go ahead and replace all of our variables with values given. So we have 3.14 times 2 times 5 plus 3.14 times 2 to the second power. So let's go ahead and simplify it. We have 31.4 plus 12.56, giving us an answer of 43.95 feet squared. Now let's look at example 3. For example 3, it is asking us to find the surface area of a sphere with a radius of 10 feet. So let's go back to our formula, which is 4 times pi times radius squared. So we are going to replace the variables with the values given. So in this case, it's 4 times 3.14 times 10 squared, which gives us a total of 1,256 feet squared. Let's move on to practice 7.2 found on page 455. So for practice 7.2, we are going to complete questions 4 and 9. For question 4, you're going to find the surface area. And for question 9, you're going to choose the best answer. So take a few minutes to complete questions 4 and 9, and when you are ready to continue, press play. So let's go ahead and start with question 4. For question 4, we're going to find the surface area. So let's bring our handy dandy formula for a surface area, which in this case, it's 2 times pi times the radius times the height plus 2 times pi times radius squared. So let's go ahead and replace all of our variables with the values given. So we have 2 times 3.14 times 9 times 12 plus 2 times 3.14 times 9 squared. When we simplify that, it is 678.24 plus 508.68. So when we add those together, we get 1,186.92 inches squared. So that's the surface area. However, the question is asking us to give us the answer in terms of pi. So what that means is that we are going to divide our answer. So we're going to divide 1,186.92 divided by pi, which is 3.14, which gives us an answer of 378 pi, which is essentially the same thing. We're multiplying 378 times 3.4, and it'll give us the other answer. So let's move on to question 9. In a cylinder, the diameter of the circular base is equal to the height of the cylinder. What is the surface area of the cylinder to the nearest square inch? So here we have a cylinder with a diameter of 6 inches. So the surface area formula is 2 times pi times radius times height plus 2 times pi times radius squared. Well, in this case, we were given the diameter. We were not given the radius. However, the radius is half of the diameter. Therefore, the radius in this case is 3, because 3 is half of 6. So we are going to replace all of our variables with the values. So we have 2 times 3.14 times the radius, which is 3, times the height, which is 6. Because remember, on the question, it says that the height is equal to the circular base. And we're going to add 2 plus times 3.14 times 3 squared, which gives us a total of 169.56. However, we want to round it off to the nearest square inch. So then our answer will be 170. At this time, pause the video, complete practice questions 1 through 3 and 6 through 8. Click play when you are ready to continue. Hi, I hope you're still there. So I am checking in because lesson 6 and lesson 7 were a little too long for my taste. But don't worry, we're almost at the end of the chapter. We only have 2 more lessons to go, and I am with you still here. I'm not going anywhere, and we are going to finish strong. So bear with me a couple more minutes, I should say, right? Let's move on to lesson 8, combined figures. So combined figures are 2 or more regular figures or geometric shapes that are combined to make a new shape. In order to calculate the perimeter of a combined figure, you need to add the lengths of the sides, and sometimes you may need to solve for a missing length. So let's look at our first example. For example 1, we are being asked to find the missing measurement. So as you can look at the figure, it is a combined figure as it is a mixture of 2 separate shapes. Now we have 2 variables in there, which means that those are unknown values. But don't worry, we're going to solve for those unknown values. So we know that this looks like a rectangular shape, although it is missing a portion of it, but it's still a rectangular shape. So just by being a rectangular shape, we know that opposite sides are equal, or opposite walls. So therefore, we know that the variable of x equals 8 plus 4. 8 and 4 are opposite of x. We need to add those together in order to get the value of our x, of our variable x. For y, it's going to be the same thing. They're opposite walls from each other. But in this instance, we have to subtract because in this instance, we're taking away a piece. So it's going to be 18, which is the top wall. And then we're going to subtract the 10 from it, which is the bottom wall, which is going to give us that one small piece that represents y. So x is 12 and y equals 8. So now we're going to add the sides, the lengths of the sides, in order to calculate the perimeter. In this case, we're going to add 12, 8, 18, 4, and 10. And it's going to give us a total of 60 feet. So what happens when we have to calculate the area or a volume? Well, it gets a little tricky, but let's focus on calculating the area first. So in order to calculate the area of a combined figure, we have to use several different formulas. And the reason why is because the first step in calculating the area, it's going to be to divide the figure into 2 shapes. So for example, in this figure here, for example 2, we divided the shape into 2 different shapes. So we get a rectangle and a trapezoid. So the rectangle is a top shape and the rectangle is the top shape and then the trapezoid is the bottom shape. So then we're going to calculate the area of each shape. You remember those formulas? If not, it's okay. You can always go back and just get a little refresher. The area of a rectangle is length times the width. So let's just look then at the rectangle. The length is 2 centimeters and the width is 5 centimeters, which gives us a total of 10. Therefore, the area of the rectangle is 10 centimeters. Now let's calculate the area for the trapezoid. For the trapezoid, the area equals 1/2 times its height times base 1 plus base 2. So let's enter our values for the different variables. So we have 1/2 and 1/2, and the height is 3. Do you know why? Well, when we separated the rectangle and the trapezoid, if you notice on the left-hand side where it says 5 centimeters for the length of the combined figure, but we are not calculating for 5 centimeters because 5 centimeters belongs to the entire figure. We only want the length of the trapezoid itself. So it's 3 centimeters because 2 of those centimeters belong to the rectangle. So that's why we're using the number 3. Now we're going to times that or multiply it by base 1, which is 5 centimeters, and base 2, which is 7 centimeters. And it gives us a total of 18 squared centimeters. So once we have the area for both separate shapes, we're going to combine them. When we combine them, we have 10 plus 18, which gives us a total of 28 squared centimeters. Now let's look at finding the volume of a combined figure. In order to calculate the volume, it's going to be the exact same thing as calculating the area. We are going to apply the correct formula for each part. So let's look at example 3. We have a cone and a cylinder together. So we need to find the volume of the container. Well, first things first, we have to divide the figures into 2 shapes. In this example, we have 2 3-sided or 3-dimensional shapes. One is the cone and the other one is the cylinder. So now we have to calculate the volume for each shape. Once again, if you need a refresher with the formulas, it's okay. You can always go back to previous lessons. So let's start with the volume of the cylinder. The cylinder is, the formula to calculate the cylinder is pi times radius squared times the height. So we're going to replace the values with the variables. In this case, we already know that pi is 3.14 times the radius. So the diagram is showing us that the radius is 1 meter. And so it's going to be 1 meter squared. And then the height. So we're only looking at the height of the cylinder, not the height of the entire object. So the cylinder is only 2 meters long, which it's going to be our height here in our formula. So when we calculate all of that, we get 6.8 meters cubic. I'm sorry, cubic meters. I could not remember. So it's 6.8 cubic meters. Now let's look at the cone. So the formula to find the volume of a cone is 1/3 times pi times r squared times the height. So remember, we're only focusing on the cone itself. So we have 1/3 times 3.14, which is pi. So you may be wondering, why are we using 1 as a radius if 1 is located in the cylinder side? Well, remember that a cylinder, the top base and the bottom base have the same volume. So that is why we're using the same radius in this instance. Think of a tomato can soup. The top and the bottom circular shape, they are the same size. And then you're going to multiply by the height of the cone, which is 1.5. When we calculate all of that together, it gives us a total of 1.57 cubic meters. The next step is to combine them. So let's go ahead and do that. So we have 6.8 cubic meters plus 1.57, which gives us a total volume of 7.85 cubic meters. Not bad, right? Now let's move on to practice 8, found on page 337. For practice 8, we are going to work on questions 3 and 4. For question 3, you're going to find the perimeter and the area. And for question 4, you're going to find the volume. So take a few minutes to complete these questions. If you need some assistance, go back to the previous slides, or if you need some assistance with the formulas to find volume, perimeter, and area, I would suggest to go to the previous lessons as well. And don't forget to use your book. So take a few minutes, and then when you're ready to come back to review them together, go ahead and press play. So let's go ahead and get started. We're going to work on question 3. For question 3, it wants us to find the area and perimeter of the given shape. So we have a shape here. It looks like a boat, but we don't know if it's a boat. It's just a combined figure. Remember, it's two or more geometrical shapes combined together in order to make one shape. So in order to find the area of this figure, we have to divide the figure first into two shapes. So in this case, we have two trapezoids. So if you can see my dotted line right where the number 6 is at, that's where we are going to separate or split both shapes, and we come out with two different trapezoids. So now we have to calculate the area of each shape. In order to calculate it, we have to have the formula for the area, remember? So let's work on trapezoid 1, which is going to be the trapezoid on the left-hand side. If the area is half times its height times base 1 plus base 2. So let's go ahead and replace the variables with the values of the trapezoid on the left-hand side only. So the area equals 1/2 times its height. So the height for the first trapezoid is 12. As you can see, the top says when we broke it up, the middle is 6 and 6. We have two separate 6s, but when we combine them, that is 12. So that is the total height of the first trapezoid. Then we're going to multiply it by base 1, which is 12, and base added to base 2, which is 3. When we calculate that formula, we have 90 squared centimeters. Perfect. So now let's move on to finding the area of the second trapezoid, which is going to be on the right-hand side. So the area, once again, equals 1/2 times the height times base 1 plus base 2. So let's replace our values with the variables. We have 1/2 times 6. Well, now we're only using half of the height that we use on trapezoid 1. Because if you look at trapezoid 2, it is a smaller one, and it's only using half of the height that the other trapezoid is using. Therefore, we're only going to use 6. And base 1 equals 17, and base 2 is 9. So when we calculate that formula, we have a total of 78 squared centimeters. Now let's combine them. 90 plus 78 equals 168 squared centimeters. Perfect. I hope you got this correct. If not, you can go through it again one more time. Use your formulas in the book. So now let's find the perimeter for this question. So the perimeter, remember, in order to find the perimeter, we have to sum all sides. So in this case, each side has a value or has a measurement. So what we're going to do is we're going to add all of those sides together except the measurement of number 6, the one that's right smack dab in the middle of the trapezoid, because we don't need that at this time. Remember, we are finding the perimeter of the shape, so we have to use only the outside sides, not the inside ones. When we get that, when we grab all the numbers, we have 12 plus 15 plus 12 plus 10 plus 17 plus 6, which gives us a total of 72 units. So therefore, our perimeter for question 3 is 72 units. Let's focus now on question 4. For question 4, we're going to find the volume for the figure on the screen. So let's go ahead and start by separating the figure into 2 separate shapes. So in this case, when we separate them, we have a square, which is your right shape, and then a rectangle, which is the shape on the left. So let's calculate the volume for each figure. Now remember, for the square, we have a formula that the volume equals the measurement of the edge to the 3rd power. So in this case, as you can notice that the square has a side length of 5. Because it's a square, all of the sides are the same. Therefore, we have 5 to the 3rd power, which gives us a total of 125. Now let's look at the other shape. The other shape is a rectangle. So we're going to take the formula to find the volume of a rectangle, which is the base, which is the length times its width, times the height. So let's go ahead and replace the value, or replace the variables with the values given. The base, we have length times width, which is 5 times 4 times the height, which is 3. So that gives us a total of 60. We are then going to combine those numbers, which is 125 plus 60, which gives us an answer of 185 cubic units. At this time, pause the video, complete practice questions 1 through 2 and 5 through 8. Click play when you are ready to continue. Let's move on to lesson 9, Geometry Calculator Skills. In chapter 5, we learn how to use a calculator when calculating algebraic expressions. In this instance, or for this lesson, we are going to use the calculator to calculate geometric shapes or geometric calculations and formulas. So the use of a calculator saves you time when solving problems with formula. Once again, we are going to use a scientific calculator. So for the GED mathematical reasoning test, you are allowed to use a TI 30XS multi-view calculator. When entering your formulas into the calculator to solve, please remember to follow the order of operations, which you learned in Chapter 5. Doing the order of operation is going to give you the correct answer. So just a little overview of the order of operations is you have to do first any parentheses or any other grouping symbols that enclose operations. After that, you do your exponents and your roots. Then you move on to multiplication and then division from left to right. And then finally, you end with an addition and or subtraction, moving from left to right. Once you enter all your formulas into the calculator, make sure that you revise your work by re-entering the sequence. So try it more than one time just to make sure that you are correct. Let's look at a couple examples on how to use a calculator in order to solve for geometric formulas. Let's look at example 1. A pyramid has a height of 81 feet. The base is in the shape of a square with each side measuring 40 feet. What is the volume in cubic feet of the pyramid? So let's go ahead and start with finding the formula that we are going to need in order to measure for the volume of a pyramid, which is 1/3 times the base times the height. But remember, the B in this case is area of the base because it is a square. So it's a squared base. And the area to find a square is side to the second power. Then H equals height. So when we replace the values using when we replace the variables using the values that are given in the example, it says that the pyramid has a height of 81 feet, and then the base is in the shape of a square, so each side measuring 40 feet. So let's go ahead and use those numbers and replace them with the variables. So it's going to look like this. It's going to look 1/3 times the area of the base, which is 40 squared, times the height, which is 81. So now when you're entering it to your calculator, you're going to break the equation into separate parts. Always remember to go by your order of operations. So let's start first with the exponent. So on your calculator, you're going to type in 40 to the x squared. Remember that there is a button with the x squared, which is 1, 2, 3, fourth button up on the left-hand side. If you have a different calculator, a TI-36, I believe it's still in the same place, but don't worry. Most scientific calculators have the same values or have the same buttons. They're probably just in a different order or different position. So become familiar with your calculator in order to use it a little bit better. So then we're going to multiply by 81. So you have the multiplication symbol, and then you're going to add 81. And then you're going to divide by 3, and you're going to press enter. So that's going to give you an answer of 43,200 feet. Okay? Oh, cubic feet. Sorry, we are measuring volume in this case, right? So it's 43,200 cubic feet. That is the volume of the pyramid. So this is entering the formula onto the calculator in separate parts. However, if you want to enter it in one series of keystrokes, you can definitely do that too. So this is the way that you will enter it on your calculator when you are measuring or calculating for the volume of a pyramid using the 1/3 times the area of the base times its height formula. Let's look at example 2. A right triangle has legs 10 inches and 24 inches in length. What is the length of the hypotenuse? Do you remember the hypotenuse? Okay, so anytime you mention or you read where it says hypotenuse, think the Pythagorean relationship. Do you remember that now? Is it coming back? I hope it is. So the Pythagorean relationship is a squared plus b squared equals c squared. So pretty much it means that leg A plus leg B equals the diagonal line of the hypotenuse in the triangle. So we have leg A, which is 10 inches, leg B, 24 inches, and then we're still missing. So we're missing the hypotenuse. We don't know the measurement of the hypotenuse. You can do it by hand. I have faith in you, and I'm pretty sure you'll get it correct. But this lesson is teaching you how to use a calculator. So let's go ahead and show you how to use a calculator. So this is the way that you're going to enter your values onto the calculator in order to get the hypotenuse. So leg A, we have 10, and you're going to take it to the second power. Then you're going to add it to leg 2 that you're also going to take to the second power. And then you're going to push enter. So when you press enter, your display is going to state 676. However, that is not the answer because remember we have c squared. So what you do is now you want the square root of 676. So what you're going to do is you're going to press the second button or the second key button that's on your calculator. If you look at this calculator, the second key is green. So when you push that second key, it means that you want a function above the one that's on the keystroke. So in this case, when you push the second, it means that you want a formula or a keystroke that's right above, and you can definitely identify them here because they're all green. And then you're going to do the x squared because you're looking for the square root of 676. And you enter 676 and you push enter. By doing so, you're going to get the length of the hypotenuse, which is 26 inches long. Let's move on to practice 9, found on page 409. For practice 9, we are going to be completing questions 6 and 8. Use a calculator to evaluate question 6 and choose the best answer for question number 8. Take a few minutes to answer both questions, and when you are ready to review them together, press play. Let's look at question 6. For question 6, we are being asked to use a calculator to evaluate and to find the volume of a cone. So question 6 reads, find the volume of a cone with a radius of 12 centimeters and a height of 20 centimeters. Round to the nearest cubic centimeters. So first off, we need to know which formula we are using. And in this case, we know it's going to be a volume formula, and it's going to be the formula used to find the volume of a cone, which is volume equals 1/3 times pi times radius squared times height. So now let's replace the variables with the values given in the question. So we have 1/3 times 3.14, which is pi, 12 squared, which is radius, and the height of 20. So the next thing that we're going to do in order to use our calculator to calculate the volume, we are going to break the formula into parts. Remember your order of operations. You have to follow which order it tells you first, because otherwise you will get the wrong answer. So let's start with the exponent. So we're going to evaluate the exponent. In this case, it's going to be 12x squared. And then you're going to multiply by pi, which is 3.14. And then you're going to multiply by 20. And finally, divide by 3 and press enter on your calculator, which will give us an answer of 3,014 cubic centimeters. Now, let's look at question 8. We are to choose the best answer. So let's read it together. To the nearest cubic meter, what is the volume of a cylinder with a radius of 1.5 meters and a height of 5 meters? So we need our formula first and foremost. And here is the formula to calculate the volume of a cylinder, which is volume equals 1/3 times pi times radius squared times the height. So now we are going to replace all of our variables with the numbers given, which is 1/3 times 3.14 times 1.5 squared times 5. Only in this case, for this particular question, what we're going to do is that we are not going to break the formula into parts. Instead, what we are going to do is we are just going to go ahead and put it into one simple keystroke, okay? Which is what we're going to do at this time. The way that you do that is going to be the following way. That's how you're going to enter it or input it onto your calculator. We have the button for pi, which is on your calculator, times 1.5 and then x squared times 5, and then you're going to push enter, which will give you an answer of 35 cubic meters. So in this case, the answer for number 8 is B. At this time, pause the video, complete practice questions 1 through 5, question 7, and questions 9 through 10. Click play when you are ready to continue. Congratulations, we have finally completed Unit 2 Mathematical Reasoning. Great job, everyone. Please keep going. The next video will cover Unit 3 Social Studies, Chapter 1 Social Studies Practices. See you soon.